Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled, Will the Sun Turn into a White Dwarf When It Dies? Now, according to accepted theory, stars are powered by thermonuclear reactions from their interiors and are made entirely of gas. Once a star runs out of fuel to power the thermonuclear reactions, the star first expands outwards as it burns what is left in its outer layers, but then releases its outer layers whilst its inner layers collapse under their own gravity, and the star becomes a white dwarf, or a very bright and dense but much smaller star than before. And here we see an artist's impression of a white dwarf. And it's a very small, very dense star, but very bright. However, the observation of the Planet X system stellar cores in the solar system as they interact with the sun has led to the understanding that these objects are dead and that they show us what happens to stars when they die. Dead stars are depleted in both energy and electrons, and since energy is related to their gravitational influence, stars end up with very little gravity. Their low energy status also means that they are not able to emit light, as they will no longer be able to generate an electric field high enough to lead to light emission from their atmospheres. And you may get some details on this from article 184 entitled Stellar Core Evolution. In addition, it has become very clear that stellar cores are what is left of a planet or star, and that they all have solid surfaces and also lose their outer layers, which are also made of solid or semi-solid material. This means that all objects, be they stars or planets, have solid cores. In addition, it has become obvious that the sun can go dark, which makes it impossible for it to be powered by thermonuclear reactions. And you may look at article 232 entitled The Sun Can Go Dark, the implications, for more details. Instead, the sun, like the planet, is powered by radioactive decay or fission in its core. And you may look at article 192 entitled Neutron Stars and Fission as a Star's Internal Energy Source for more details on that. Thus, a dead star is in many ways the opposite of what a white dwarf is envisioned to be by accepted theory. There is, however, one aspect about white dwarfs which is similar to real dead stars or stellar cores, and that is the drawing of matter from a companion star. As a white dwarf is able to draw matter from a companion star close by, the stellar cores are able to draw matter from the sun. They are in addition able to draw energy from it, which slowly destroys the sun. So you see here an artist's impression of a white dwarf drawing matter from a companion star, a main sequence star, and it leads to the creation of this accretion disk around the white dwarf. But the stellar cores are known to draw matter from the sun. So we can see they make this vortex matter connection with the sun. They connect to the sun through this. And you can see it here in several wavelengths. And this is one of the dark stellar cores, and therefore one of the newer arrivals at the sun at that time. This is from 2012. And it's also one of the smaller ones. This object had a radius of only about half the radius of Jupiter. In addition, it has become clear from observing stellar cores in the sun's corona that the mechanism behind the star's light emission is electrical in nature, and it takes a star with plenty of photon energy in its particles to generate a large enough electrical field or electrical potential difference between its core and its outer negative layer to emit light in its atmosphere. You may look at article 203 entitled Stellar Cores Drawing Energy from the Sun for more details on that. This light emission occurs as a result of electrical discharges or lightning. Thus, a small, very bright star, as white dwarfs are described to be, would have to be the opposite of a dead star. Instead, a white dwarf would have to be a very young star with more energy in its particles than the average star. And for more details on that, you may look at article 254 entitled Planetary Nebula and Death of a Star. In conclusion, accepted theories and vision of a white dwarf star has one thing in common with real dead or energy depleted stars. They draw matter from a main sequence star, as the stellar cores are doing from the sun. However, the fact that stars which are referred to as white dwarf stars are very bright indicates that they are actually very young stars with large reservoirs of photon energy in their particles. And this is Dr. Claudia Albers, Planet X physicist. Thank you for watching.